you go. All right. So first and foremost, guys, if you are not happy with your balancing and reactions test, you're welcome to retake it through this Friday. Now today is Wednesday, and Friday is in 2 days. So you have about 52 hours if you want to do the retake. That being said, now we're going to transition to what's called stoichiometry. Stoichiometry is using balanced chemical reactions to find masses. But before we do that, a small part of what we're going to be talking about today, or a small part of stoichiometry, and what we're going to be talking about today is formula, mass, and mass percent. So if you look at something and you're like, okay, I got a chemical that's XY, how much is X? And how much is Y? What do you think? If you had a formula that was XY, could you just look at that and say, I know how much is X and how much is Y?
No.
Could you do it?
No.
Why?
Because you don't have any.
Because they could be anything, exactly. Yeah, they could be anything. You don't be like, oh, it's 50% X, 50% Y. No, they could be anything. Just like if you had H2O, you can't say, well, that's 2 parts H and 1 part O, because H has a mass of 1, and O has a mass of not anything. 16, right? Okay, so if we want to figure out the percentage, if you want to figure out the percentage of right-handed people in the room versus left-handed people, how would we do it?
Raise your hand if you're right and raise your hand if you're left-handed.
Take a survey.
Yeah, and then count them, right? Weigh them all. Weigh the number of people who know. Count them, right? So we count them, and we get an average, or we get a number, and what would we do with that number?
You would write it down for data.
We put the number of the right-handed, and we put that over
Number of the left. The total.
total number, right? Total number. Well,
Can you
see that? So if we wanted to know the percentage of people in the class who were right-handed, we would count the number who were right-handed, and then we put that over the total number. Well, we do that in chemistry as well. So if we want to know what percentage of water is hydrogen, we count how many grams of hydrogen we have, and we put it over the entire thing. So if you have H2O, water. So if you had H2O, how many grams is just hydrogen? 2 grams. So you got 2 grams of hydrogen, and the entire thing is how much? 18 grams, because 16 plus 2 is usually 18. And if you, this is for the hydrogen. So, and if you wanted the oxygen, then what would you do? 16 over 18. And hopefully, when that's going to give you a percentage, that's going to give you a percentage, and hopefully those 2 percentages would equal what? 100%. Kind of get this?
Yes. Yeah.
Now that's what we're going to do today in lab. Interesting things happened in about 30 years ago. We had all these pennies, and the pennies used to be made out of pure copper.
But not anymore.
But not anymore. Now, they're not made of pure copper. They are what's called copper-clad zinc. So you got this zinc pellet, thin zinc pellet, and around the zinc pellet is a very thin layer of copper.
Do it quickly.
So we got zinc in the middle and a very thin layer of copper. Do you know why they did that? Copper is too expensive, exactly. It turns out copper was really good at making wires and everything else, mostly wires. And we needed wires for telecommunications, which became a big deal in the 20th century. You might be familiar with it. So what we're going to do is we're going to figure out how much of our penny is copper and how much is zinc. And the way we're going to do that is we're going to get rid of one of the 2 things. We're going to do a chemical reaction that will attack zinc but won't attack copper. Anyone know what we're going to use?
Zinc oxide.
Yeah, which acid?
What did you just say?
Cannon.
Hydrochloric, right front. So when hydrochloric acid, which is aqueous, encounters When hydrochloric acid, which is aqueous, encounters zinc, It makes hydrogen gas, which is great, and this is solid, and it makes zinc chloride, which is going to be more or less ignored at this point. Okay? And the way we're going to do that is we got to get to the zinc somehow, but not rub off all the copper, because we care about the copper. So, what you're going to do is you're going to take your penny, you get your penny, and around your penny, you're going to make 3 marks, like the Mercedes symbol. You're going to put one up there, one down there, and one down there. So, get yourself a file, penny, and you're going to set your penny down and go rub, 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 turn, rub, 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 turn, rub, rub, rub. If you can see the silvery colored zinc, then you're good to go. Then you're going to put this in 4 molar hydrochloric acid, which is why you're going to be wearing glasses. Because hydrochloric acid will hurt you. It'll also hurt your clothes. You won't know it's hurt your clothes until after you do the wash and like, how come my favorite shirt has holes all over it? Because you weren't paying attention.
That sounds like Mickey Mouse.
Okay, anyway, so far so good? Guys, do you have any questions? Since you're talking, I'm assuming you have questions. All right, so each person's going to get their own penny, and you're going to go scratch, 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 and then write down the year of your penny. Please don't get the same year as somebody else, because they're going to be pretty close to be like, hey, we both had 1998. Oh no! So get a different year, so that way you know what your penny is. Weigh your penny after you've made the scratches. Put it in a beaker. Pour some hydrochloric acid into the beaker. The amount is written on your lap. And then you're going to put a petri dish over your beaker, or over there, and then label your petri dish with tape. That way you know whose beaker it is, because this time tomorrow, there's going to be 50 beakers in the fume hood. Okay? So, beaker, penny that's been scratched into the beaker, add your acid carefully. Don't go, hey, I got a beaker of acid. Because then you're going to lose your favorite shirt. There's little spots all over. Okay, so just drop in there carefully, and then put your petri dish on top, tape over the petri dish, put it in the fume hood, and then have a seat. Okay? Now, if you have questions about what you're about to do, put your hands up and wave it around.
Are we sharing a beaker or just are we eating one?
Yeah, 1 beaker per group. 1 beaker per group. And teams no larger than 3, please. Let's put 3 pennies in each beaker. We have seen sometimes you're like, I put 6 pennies in 1 beaker, and 4 of them didn't work. Well, there's only so much acid in the
You want to be
beaker.
my room now?
Okay, question. Okay, so 3 people per group, 3 people per beaker. Any other questions? All right, so in just a second, the following things are going to happen. Guys, I know you're like, let's get a good group. In just a second, the following things are going to happen. Laura's going to press the silver button. You're all going to get goggles, and then one person's going to come select a penny for each person in the group.
I'll do that.
Okay, go for it.
I'll get the file.